Scalar quantity. Any quantity which has only magnitude but no direction is called a scalar quantity. What are the examples of scalar quantities in our practical life? You can just think of what are scalar quantities that you see in day-to-day life. Can I say distance is a scalar quantity? Yes. Distance from this particular institute to your home is 20 kilometers. 20 kilometers is a scalar quantity because it has only magnitude but no direction. Can anyone tell me some other examples for scalar quantities which we see in day-to-day life? Distance is one of it. Can we call speed as scalar quantity? Speed is basically, what's the formula for speed? Speed is basically distance by time. Where distance is a scalar quantity, time in general don't have any direction. Therefore, time is also a scalar quantity. And if you take distance by time, scalar by scalar is one more scalar quantity. Therefore, we can say speed is also a scalar quantity. Any other examples for scalar quantities that we come across other than speed, distance, and time? If I take displacement, can I say displacement is a scalar quantity? When I say displacement, I generally say displacement is 30 units in one particular direction. For example, it is x direction, then you take x, which is unit vector along x direction. That means displacement has both magnitude and direction. That's why it is different from distance. We don't categorize them into the quantity of scalar quantities. Displacement is basically a vector quantity. We take in parallel the understanding of vector quantities also. Other than this, if you take work done, work done generally, how much work done we say generally? Work done is like 20 joules, 30 joules, 40 joules. It don't have any direction. Therefore, basically, work done is also a scalar quantity. These are all day-to-day life quantities which are scalar quantities. If you take electrical quantities, what is a scalar quantity? Electrical quantity. We can take electric potential. In simple words, voltage. Voltage is a scalar quantity. How do you measure voltage? We say voltage at a given point is 3 volts. We don't have any direction for that. Am I right? So that's why electric potential is a scalar quantity. If you go for electric field, for example, in x direction, electric field is there. Then it is electric field is something like 3ax plus 4ay plus 5az. I try to write it here. Electric field intensity E. For example, it is 3ax plus 4ay plus 5az. That means this field quantity has both magnitude as well as direction. It has magnitudes in x direction, y direction, and z direction. Therefore, naturally, this electric field quantity is a vector quantity, unlike electric potential. These are the basic examples of scalar quantities. If I take electric potential, which is V, which is a scalar quantity, and if I take electric current, it's a very interesting example is electric current. Is electric current I, is it a scalar quantity? Now let me know the definition of electric current. Electric current is something which has both magnitude and direction. That's the basic definition. But my doubt is this electric current a scalar quantity or a vector quantity? We'll have this discussion once we move forward into the subject, whether this electric current is a scalar quantity or a vector quantity. For now, we'll keep it aside. Similarly, one more interesting example is your mass. Mass is generally have For example, I take my own weight is around 60 kg. 60 kgs is a scalar quantity. If you take weight, is weight and mass are same? If they are same, they both are scalar quantities or vector quantities. Mass is scalar quantity, that is clear. How about weight? I'll try to keep this in a box. We'll come back to weight also. Once we gain more knowledge about scalars and vectors, as we move into the subject, we try to solve these two questions, which is electric current and weight. Coming back to vector quantities, a vector is one which has both magnitude and direction. Basic example for vector quantities include, as I discussed previously, which is displacement, electric field, magnetic field, force. Force is also something which has direction. Velocity. You can see the difference here that is to be identified. I said speed here, which is scalar quantity, because the basic definition for speed is distance by time. Distance is scalar quantity, time is scalar quantity, and the division of two scalar quantities results in a scalar quantity. Therefore, speed is a scalar quantity. If you see velocity, unlike speed, velocity is displacement by time. You already know displacement is a vector quantity. A vector by scalar results in a vector quantity. Therefore, velocity is a vector quantity. And the point to be noted is both velocity and speed has same unit, meter per second and meter per second. But one is scalar quantity, the other is a vector quantity. Similarly, we electrical people are more familiar with this term called torque, which is a rotational force, which is also a vector quantity. These are the basic examples for scalars and vectors. We try to move ahead to the next topic, which is a unit vector.